this is lesson 1-6, solving linear inequalities. So inequalities equal right here, an equation, but inequalities. So we're not doing equal signs, we're doing our inequality signs. So linear inequality is in one variable can be written in one of the following forms. So ax plus b, and then is greater than 0. This looks like our linear equation, but it's got an inequality sign. Or you could say ax plus b is greater than or equal to 0. Or you could say ax plus b is less than 0. Or ax plus b is less than or equal to 0. So you should be able to tell the difference between a greater than and a less than sign. If it's greater than, it opens to the left. If it's less than, it opens to the right. And the way I always think about it, if you remember the alligator wants to eat the bigger number. So if it's open towards the thing on the left, it means that's the bigger number. 2, a compound inequality consists of two simple inequalities joined by and or. Okay, so compound inequalities, we're going to push two inequalities together, and we're going to use the word and or, and they'll look different depending on which word. Equivalent inequalities, equivalent, again, equal, have the same solutions as the original equality. So 4a says graph x is less than or equal to 4. So 4 is my main number. One number smaller is 3. One number bigger is 5. And I'm going to draw a circle here. But if you look at this, I have the less than or equal to. And with that equal to sign, that means I need to color it in. If there was just a less than sign, I would leave it just an open circle. And then x has to be less than or equal to 4, so less than would go in this direction. The end point for this is closed, because again we had the equal sign. B here, well, let's start, the end point is going to be, if you look at it, we just have the greater than sign, so the end point is going to be just an open circle. And it's -2 is our number, so I'll go one smaller, -3, one bigger, -1. We know we want an open circle on -2, and this says x is greater than -2. So we're going to shade the greater than side. Okay, graph compound inequalities. So looking at this one, I have x is in the middle, and x, notice it's open towards the x, so this is saying x is greater than -3. So x is greater than -3. And when they're connected like this, that means it's an and. And then x is less than 1. So and x is less than 1. That's what this compound inequality is really telling me. So you can split it up and write x twice. But make sure the sign still opens towards what it opens to here. So this opens to the x, so it needs to open to the x here. This one opens towards the 1, so it needs to open towards the 1 here. So let's graph this. So x has to be greater than -3. So start with -3, -2, but it's got to be less than 1. -1, 0, 1, 2. And let me just change my color so you can see it a little better. So it's greater than -3, so I'm going to have an open circle since there's no equal to sign. And it's got to be greater than it, so it's going to go this way. And it's less than 1, again, just an open circle because there's no equal to sign. And then we're going to shade the middle. So the solutions are between -3 and 1. The solutions are greater than -3 and less than 1. Looking at this next problem here, it says graph x is less than -1 or x is greater than or equal to 1. So this is written as two separate inequalities already. We don't need to split it up. So -1 is going to be our smallest. I've got 0 and I've got 1. Okay, x has to be, let me change my pen so you can see it again. X has to be less than -1. There's no equal to sign again, so it's an open circle. or x has to be greater than or equal to 1. Now here's my circle on 1, but it's greater than or equal to, so we need to shade this. And then it's going to go in this direction, and we'll draw our arrow. So the solutions are less than -1 or greater than or equal to 1. Move my page up here, and we're going to do a little work with inequalities. We're going to do a little discovery first. It says when you solve inequalities, do the inequality signs, I should say signs, always remain the same? The given inequality is true. Perform the indicated operation on both sides and determine if the inequality sign remains the same. So here I have -6 is less than 10. I'm going to add 5 to both sides. So -6 plus 5 is -1. 10 plus 5 is 15. Is this sign still true? Is -1 less than 15? Well, yes it is. So it stays the same when I just add 5. B, we have -6 and 10, and we're going to subtract 5 from both. So -6 minus 5 is -11, or 10 minus 5 is 5. Let's see, is this still the same? Is -11 less than 5? Well, yes, it is. So subtracting 5 didn't change the sign. For C, we're going to multiply both sides by 5 here. So -6 times 5 is -30. 10 times 5 is 50. Our sign up here is less than. Is -30 less than 50? Yep. So the sign did not change when I multiplied by a positive 5. Let's look here. We're going to multiply by -5. So -6 times -5 is positive 30. 10 times -5 is -50. My sign here was less than. Is 30 less than -50? It's not. So this sign actually switches. And notice multiplying by a negative number switched the sign of the -6 and it switched the sign of the 10. So our inequality sign has to switch also. So the inequality switches direction when you multiply. I should say, and I don't have a space, multiply. Let's look at this last one. We're going to divide this one for E. We're going to divide both sides by 2. -6 divided by 2 is -3. 10 divided by 2 is 5. This sign is less than. Well, is that the same? Is -3 less than 5? Yes, it is. So dividing by positive 2 kept the sign the same. For F, I'm going to divide both sides by -2. -6 divided by -2 is positive 3. 10 divided by -2 is -5. Now look at -6 to 3, opposite sign. 10 to -5, opposite sign. So dividing by negative switched the sign of the number. Let's see if it switches the inequality sign. We had a less than here. Let's see if less than works. Is 3 less than -5? No, 3 is greater than. So the inequality switches directions when you multiply or divide both sides by a negative. And this is something you've seen before, so hopefully this is just a great reminder for you that this is when you switch your signs. So for 6 here, we're going to solve these and then we're going to graph them. So solve and graph, just like a regular equation, I want to move my variables to the same side. Here's my middle, just in case we forget. So I will move my 9x to the left, just because I think a lot of you like to move everything to the left. So 4x minus 9x is -5x plus 5, and it's still less than -10 because all I did was subtract a number. I'm going to move this 5 by subtracting it. So I have -10. I just subtracted a number. My sign stays the same, and over here I have -5x. I need to move that -5, so I have to divide by -5, and since I divided by a negative, my sign changes. So I have x is greater than -10 divided by -5 is positive 2. And I did that wrong. -10 minus 5 is not -10. Silly me. That's -15. -15 divided by -5 is 3. So it's x is greater than 3. So my graph here, I need a 3 in the middle. 2 is 1 below. 4 is 1 higher. X is greater than 3 is an open circle because there's no equal to. And then we're going to shade to the right. For number 7, solve and graph it. Now this is a compound inequality, so you look at the middle, and whatever you undo in the middle, you have to undo both sides by. So in the middle, I have 5x minus 2, so I want to start by moving that 2, and I have to add it to both of the sides. So that'll cancel. I have 5x still in the middle. I added a positive, so my signs still stay. Negative 7 plus 2 is negative 5. 8 plus 2 is 10. In the middle, I've got to get rid of this 5, so I'm going to divide everything by 5 here. I divided by a positive number, so my signs still stay the same. So my signs are staying the same. 10 divided by 5 is 2. Negative 5 divided by 5 is positive 1. So my graph here, my endpoint on my left is negative 1, 0, 1. On the right, it's 2. It says x has to be greater than negative 1, so it's an open circle, and it's going to be greater than. X has to be less than or equal to positive 2. It's less than or equal to, so this one is going to be shaded in, and then I need to shade in between the middle here. All right, so flip your notes over. Let's do the second half, this other page. It says solve and graph. So now we're going to solve and graph this, but we've got an or in the middle. So we can expect our graph to have 2 points and your arrows going in separate directions. That's generally what it looks like when we have an or in the middle. So we're going to solve these two separately. Let's look at this first side. Got 4x minus 7 is less than or equal to 5. I first have to undo the minus 7, and then I'll undo the 4. So to undo minus 7, I'm going to add 7 to both sides, and these are two separate inequalities, so I'm only doing it to this one. So I have 4x is less than or equal to, I keep the same sign because all I did was add a number. It's less than or equal to 5 plus 7, which is 12. I'll now divide both sides by 4, and x is less than or equal to 12 divided by 4 is 3. And my sign did not change because I did not multiply or divide by a negative there. This other problem, 3x plus 2 is greater than or equal to 23. I first have to undo the 2 and then the 3. So I'll start by subtracting 2 from both sides. So those cancel. I have 3x. I just subtracted 2, so I don't change the sign. It stays the same. Is greater than or equal to 23 minus 2 is 21. To get x alone, I'm going to divide both sides by 3. And x is greater than or equal to, I keep the same sign because that was a positive number that I divided by. It's greater than or equal to 7. And we've got the word or in the middle here. So I need to graph this because it says solve and graph. So I need 3, 4, 5, 6, and 7. I'll just change my pen to make it look a little easier. This says x is less than or equal to 3. So I'm going to have a circle here on 3, but I need to color it in because we have the or equal to. And it's going to shade in this direction. Or x is greater than or equal to 7. So I'm an open circle on 7, but actually it needs to be closed, so we're going to color it in because it's x is greater than or equal to 7. Then we're going to shade it this way. And this is an or because you could have it in one of those two ranges, but you couldn't have a number that's both less than or equal to 3 and greater than or equal to 7. Let's look at our word problems. Okay, solve a word problem involving inequalities. So D, you budgeted $66 a month to spend on yoga classes. So here's my budget. Your yoga studio charges $22 per month. So $22 per month, that's what they charge us. The membership fee, that's the $22 per month membership fee. So you're always going to have to pay that one. Membership fee, plus $5.50 per class attended. What are the possible number of classes you can attend each month? So here is my question. What are the possible number of classes you can attend each month? And if that's what I'm looking for, that's what I'm going to make my variable. So define your variable. X is going to equal the number of classes you can attend. write an equation of inequality. So we're going to write an inequality problem. Our budget is $66 a month. Okay, so there's my budget. That's the most that I can possibly spend. So it can be equal to $66 or $66 can be bigger than it. So 66 is greater than or equal to. We know we have to pay $22 every month. Plus, we're going to pay $5.50 times every class that we attend. So there's my inequality. The next part says solve and answer the question. So I'm going to solve this by subtracting 22 from both sides. So I have 44 is greater than or equal to $5.50 times x. Divide both sides by $5.50. And x, I keep my sign exactly the same because I did not divide by a negative. And this side becomes 8. So I'm going to flip this around to make it a little more sense. X, and it's got to be open towards the 8. So x, the number of classes I can attend, has to be less than or equal to 8. So you can attend at most 8 classes. Number 10 here. It says a monitor lizard has a temperature that ranges from 18 degrees Celsius to 34 degrees Celsius. Write the range of temperatures as a compound inequality. Then write an inequality given the temperature range in degrees Fahrenheit. So 18 is the smallest, and it can be 18, so it can be equal to. And this is in Celsius, so I'm going to put a C. So 18 degrees Celsius. Or the highest that can be, so it's going to be less than or equal to, is 34 degrees Celsius. Now we want to change this over to Fahrenheit. So to change this over to Fahrenheit, we're going to substitute this right in here for the middle. So 18 degrees Celsius is less than or equal to 5/9 times the quantity F minus 32, and that's less than or equal to 34 degrees Celsius. So it's in degrees Celsius right now, but we're going to change it over to Fahrenheit. So to do this, we're going to look at the middle right here, and we're going to undo the middle things. So I start by undoing my fraction. Because this is in parentheses, I start by undoing this, and then I will undo my minus 32. So to undo that fraction, I'm just going to do a different color here. I'm going to multiply by the reciprocal by 9/5, so those will cancel. So I'm going to multiply both sides by 9/5. So 9/5 times 18. So we've got 9/5 times 18. I'm just going to keep it that value right now. It's less than or equal to, in the middle I still have F minus 32. It's less than or equal to, over here I have 9/5 times 34. I need to get this F alone, so I'm going to add 32 to both of the outsides, to all the areas, to make that cancel. So F, I did not multiply or divide by a negative, so my signs stay exactly the same. If you reduce 9/5 times 18 plus 32, you'll get 64.4, and we convert it to Fahrenheit, so this is degrees Fahrenheit. And over here, we're going to have 93.2 degrees Fahrenheit. So this is a good example of where we would actually use inequalities. This last one would be an and inequality. Please make sure if you have any questions that you star them so we can talk about them in class tomorrow, and have a great night.